Good afternoon, viewers. Welcome to my channel, Second Math Hub, the solution to your math problems. We are still solving questions on core mathematics. This is November-December 2024, the ongoing Novdec. This is theory compulsory question 4. It's a question under bearing, a very interesting one. I read, a point M is 3.2 kilometers from another point Q on a bearing of 60 degrees. So let's quickly represent the first information on the diagram. So now we have 2 points, M and then Q. The distance between these 2 points is 3.2 kilometers. But between point M and then point Q, where do we measure the bearing 60 degrees? Remember that when it comes to bearings, this is the key word. The word from tells us where to measure the given bearing. So as you can see, the point M is 3.2 kilometers from point Q. So meaning that, first of all, we need to draw our point Q. So this is point Q. And this is our geographical note. We know that when it comes to bearings, angles are measured from the geographical notes in the clockwise direction. So in the clockwise direction, we have to measure 60 degrees. 60 degrees. So 60 degrees would be somewhere. Okay, so then this is our second point. So that would be point M. This is our point M. Now, what is the distance between point Q and point M? It was giving us 3.2 kilometers. Now, let's continue. And another point, R. So another point, that is the third point, R, is 2.4 kilometers on a bearing of 150 degrees from point Q. So from point Q, we are also to measure 150 degrees. So point Q, we have to measure 150 degrees. So as we said, in bearings, angles are read from the geographical north in the clockwise direction. So from the geographical north to the east, that would be 90 degrees because it is a quadrant, 90 degrees. So 90 degrees plus what angle will give us 150 degrees. So obviously 90 plus 60 degrees will give us 150 degrees. So from this quadrant, we have to measure 60 degrees. From this quadrant, we are also to measure 60 degrees. So this will be our point R. Don't forget that from this quadrant, we measured 60 degrees. So from the geographical north to this line here measures 150 degrees because 90 degrees plus 60 will give us 150 degrees. Don't forget that the distance between point R and Q measures 2.4 kilometers. So as you can see, we are getting a triangle. So how then do we get a triangle? by joining these 2 points. So that is the A part of the question. We have to illustrate this information in a diagram. So that is what we have done. That is what we have done. Now, B. So for B, we have to answer 2 questions. We have to find the I, distance MR. So BI. You have to find the distance MR. So which distance are we looking for? We are looking for this distance, MR. You have to look for this distance. Now, let's look at something here. You know that this is a quadrant, and the total measure of a quadrant is 90 degrees. So if one part measures 60 degrees, then it means that the remaining part will also measure 30 degrees. Don't forget that the quadrant has been divided into 2. So if one part measures 60 degrees, then the remaining angle will also measure 30 degrees. So what is the sum of the interior angle at this point Q? It's 30 plus 60. This should give us 90 degrees. So we see that triangle KOMR is a right angle triangle because one of the interior angles is measuring 90 degrees. So we also know 2 sides of this right angle triangle. So how then do we calculate the distance MR? So we can refer from Pythagoras theorem. So we know that from the theorem, this is the longest side, which is the hypotenuse. Why is it the longest side? Because this side here faces the 90 degrees angle. So from Pythagoras theorem, the length of the square of the longest side, in this case, the square of line MR should be equal to the sum of the squares of the other 2 sides. So the sum of the squares of the other 2 sides. So starting with this side, 3.2 squared plus 2.4 squared. So let's simplify. Let's simplify. We have MR is equal to, so 3.2 squared should give us 10.24. Then 2.4 squared, that is giving us 5.76. So MR squared is equal to 10.24 plus 5.76. That is 16. We are looking for MR, not MR squared. So what do? We can take square root on both sides. So we have, since we are looking for MR, can take square root on both sides. So the square root and the square will cancel out, leaving MR is equal to square root of 16 is 4. Then don't forget that the distance was given in kilometers. So the distance MR will measure 4 kilometers. Now the B part. we have to find the bearing of M from R. The bearing of M from R. Want the bearing of M from R. So from R, there is our geographical note. So from the geographical note, we need to move in the clockwise direction until we get to the line that connects R and then M. So we are looking at angle theta. So this is where we have the theta. This angle will be the bearing of M from R. Now, there is also a quadrant, as you can see. You know that the total measure of a quadrant is 90 degrees. So this quadrant has been divided into two. One part measuring 60 degrees. So the remaining angle will measure 30 degrees. Don't forget that angle 30 alternates with this angle. So they are alternating. And we know that alternating angles are equal. So it is, let's calculate the value of theta. Now to do this, let's identify the remaining sides of the right angle triangle. Already we know that this side is the hypotenuse. It is the longest side. And then this angle 30 plus theta is facing this side of the triangle. So this side becomes our opposite. Then obviously the remaining side becomes the adjacent. So we know the length of the opposite, we know the length of the adjacent. So from SOHCAHTOA, which of them has opposite and adjacent? So clearly, you can see that that is TOA. And what does TOA say? TOA says that the tan of the acute angle. So we are looking at this angle, the whole of this angle. So the sum of these two angles, that is 30 plus theta, should be equal to the length of the opposite. So the opposite measures 3.2 kilometers divided by the length of the adjacent. So this side is the adjacent, measuring 2.4 kilometers. We are looking for theta. So what do we do? Let's do away with the tan by taking the tan inverse on both sides. So taking the tan inverse of tan will cancel out the tan, leaving 30 plus theta. And then the tan inverse of 3.2 divided by 2.4. So we have 30 plus theta is equal to, so let's take the tan inverse of 3.2 divided by 2.4. So we have 53.13. That is to 2 decimal places. 53.13. But our goal is to look for theta. So let's group like this. Theta is equal to 53.13 minus 30. So 53.13 minus 30. 23.13 degrees. So what is the conclusion? The conclusion is that the bearing of M, the bearing of M measures 23.13 degrees. 23.13 degrees. I hope you enjoyed this episode. Please don't forget to subscribe and share the videos for others to also benefit. Thanks for your support. See you next time.